Namaste, future Java developers. Welcome to another exciting whiteboard tutorial. Today, we are diving into a super important topic for building fast and efficient applications: database indexing strategies. Have you ever wondered how databases can find specific data incredibly quickly, even when there are millions of records? The secret often lies in indexes. In this lesson, we will understand what database indexing is, why it is crucial, and explore some common strategies. By the end of this video, you will have a solid foundational understanding of how to use indexes to boost your application's performance. Let us get started. Imagine you are looking for a specific topic in a very thick textbook. Would you read every single page from beginning to end? Of course not. You would go straight to the index at the back of the book, find your topic, and it would tell you exactly which page to turn to. A database index works in a very similar way. It is a special lookup table that the database search engine can use to speed up data retrieval operations. It is like creating a shortcut to your data. The most common type of index is called a B-tree index. Think of a B-tree as a balanced tree structure where data is sorted, allowing the database to quickly navigate through nodes to find the exact record it needs without scanning the entire table. This significantly reduces the input-output operations required, making your queries much faster. Now, let us talk about two primary types of indexes: clustered and non-clustered indexes. A clustered index determines the physical order of data in the table. Think of it like a dictionary where words are physically sorted alphabetically. The data itself is stored in the order of the index. Because the data can only be sorted in one way, a table can have only one clustered index. This type of index is excellent for range queries, or when you frequently retrieve data in a specific order. On the other hand, a non-clustered index does not change the physical order of the data. Instead, it creates a separate structure that contains the indexed column values and pointers to the actual data rows. Imagine it like the index at the back of our textbook. It points to where the information is, but the book's pages are not rearranged. A table can have multiple non-clustered indexes, making them versatile for various search criteria. Let us see a practical example to understand when and how indexes help. Suppose we have a products table with millions of entries, and we frequently search for products by their product_name. Without an index on product_name, the database would have to scan every single row in the table to find a match, which is very slow. This is called a full table scan. However, if we create an index on the product_name column, the database can use this index to quickly locate the relevant rows. Here is how you might create an index using SQL, which your Java application would then benefit from when executing queries via JDBC, the Java Database Connectivity. The Java code simply executes the query, but the underlying database performance is what indexing improves. This simple create index statement can transform a slow query into a lightning-fast one. While indexes are powerful, it is important to use them wisely. One common mistake is over-indexing. Creating too many indexes can actually slow down data modification operations like inserts, updates, and deletes, because the database has to update all associated indexes every time data changes. Another mistake is indexing columns with very low cardinality, meaning columns with very few unique values, for example, a gender column. Indexes are most effective on columns that are frequently queried, have high cardinality, and are used in where clauses join conditions or order by clauses. Always monitor your database performance and analyze query execution plans to identify bottlenecks and determine where indexes would be most beneficial. Remember, a well-placed index is a performance booster, but a poorly placed one can be a burden. Alright, my friends, we have covered a lot today about database indexing strategies. We learned that indexes are like shortcuts that significantly speed up data retrieval, just like a book's index. We explored the common B-tree index structure and understood the key differences between clustered indexes, which physically order data, and non-clustered indexes, which use pointers. We also saw a practical example of how an index can improve query performance and discussed important best practices, like avoiding over-indexing and choosing high cardinality columns. Understanding indexing is a fundamental skill for any Java developer working with databases. Keep practicing, keep experimenting, and keep building amazing applications. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming lessons. Happy coding!